Okay, we're back at the third installment of four. I'm gonna do 20 to 30, and we'll take a little break. So at number 21, this is where we start. So here's 21. So graphing systems of inequality is when we have more than one inequality. So imagine if we have two inequalities. The first one, let's say the Romeo inequalities. It looks like Romeo can hang out above this line. And then the Juliet territory, here's her line, looks like she hangs out below this line. So where is it that Romeo and Juliet can hang out and everyone's cool? Well, A, only Romeo can hang out in A. B, nobody. C, just Juliet. So D. D is good for Romeo because he can hang out above this line. And D is good for Juliet because she hangs out below this line. And that really is the only spot out of the four that the two can hang out. So that's the same story over here. So like this is Romeo, and this here is Juliet. So Romeo equation, he starts at the y-intercept of 2, and then his slope is 1 over 3, so up 1, 3 to the right, you go down 1, 3 to the left. It has this equal to, so that makes it a solid line. And it's greater than, so it looks like Romeo hangs out above this line. Okay, that's his thing. So what about Juliet? Her thing is that the y-intercept is at -3, that's down here. And her slope is 2, so up 2, 1 to the right, up 2, 1 to the right, up 2, 1 to the right. So it looks like this is where they meet. But the territory, Juliet's territory, this is less than. So her thing is below this line. So over here, only Romeo. Over here, nobody can hang out. Over here, only Juliet. So this spot over here is where Romeo and Juliet can totally hang out, and it's all legit for both of them. So there it is. That's number 21. Alright, let's move on to 22. Alright, so rational exponents. So a rational number is like a fraction. So here's a rational exponent. I'm using letters, but here's your base and the fraction. That's a numerator and that's denominator. So we can change rational exponents to radical form. So that's the base, it still is in here, and there's a radical sign. Now the root, that's the denominator that goes in here. And then the whole thing to the power of n, which is the numerator. So let's work on these problems over here. I'm going to work on this one first because it's the easier. So this is the same thing as the radical of 16, but the root is 4. And it looks like it's to the power of 3. So this means it's a fourth root of 16. That means what times itself 4 times and give you 16? The answer is 2. Because 2 times 2 times 2 times 2 is 16. So it's just 2 to the third. And 2 to the third means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this whole thing here, that's equal to 8. Okay, so now let's work on the others. With this one, see that negative exponents? We don't like the negative exponents. So we're going to make the 25 into its reciprocal, 1 over 25. And then we're going to make it into 25 to 3 to the 25 to 3 over 2 exponent. So this is 1 over, there's the radical sign, there's the 25, that's a 2, and then the whole thing to the third power. So this here is 1 over the square root of 25 to the third power. So square root of 25 is 5, because 5 times 5 is 25. And then 5 to the third power is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So this is the same thing as 1 over 125. Okay? This one over here, notice the negative exponent? That means it's 1 over 625 to the power of 1/4. Positive exponent. So this means it's 1 over to the 4th root of 625. The whole thing to the first power, but that's kind of anything to the first power, we don't need to maybe. So what times itself 4 times, it gives you 625. As it turns out, x is equal to 5. 5 times 5, 25 times 5, 125 times 5, 625. So this would just be 1 over 5. Okay. So for 23, you have to know certain rules of exponents. The first rule is that when you multiply these powers and they have the same base, you can add the exponents. So 5 plus 2 is 8. Now, the base are the same, it's x. So what do you do with the exponents? You minus it. 7 minus 3, that's 4x to the 4. Then anything to the 0 power is 1. And then this is like a power of a power. And we multiply the exponents. X is 6. And then remember from the previous example, we don't like the negative exponents. We made it into its reciprocal. And then change the exponents positive. So for this one over here, 48 divided by 12, that's just 4 over 1. And then you see the x to the 6 and x to the 8. That's going to be x to the negative 2 over here. But since we don't like the negative exponents, we're going to bring it down to x squared. You can think about it. That's 8, that's 6. You subtract, you get 2. This one is bigger exponent, it goes down here. That's a shortcut, I suppose. Now you see y to the, that looks like to the 4, that's to the 8, the difference of 4. 8 is bigger down here, so it's going to be, oh, did I just do that? No, I just confused my x with my y. My bad. That's not good. Let's try it again. So here's the 4, y to the 4th, that's y to the 1st. We subtract y to the 3rd up here. Y to the 3rd. And then the z over the z, subtract the exponent, z to the 0, z to the 0, that's just 1. So as it turns out, there's your answer. You don't need that one. So you can just write 4y to the 3rd over x squared. There you go. And for this side, you can see that 6 over 18 divided top bottom by 6, you get, what is that, negative 1 over 3. And then x to the 3rd, x to the 7th, the difference between the two is 4. And that's going to be at the bottom. Okay? And then y, what is that, y to the 4th, that looks like it's y to the 3rd, so we subtract, which is y to the 1st. And then z to the 5th, z to the 2nd, we subtract 5 over 2, that's just going to be z to the 3rd. So negative 1, all that. I suppose you don't like to need to write the negative 1, you just have to write the negative sign. Anyway, I'm sticking with that answer. Alright, so number 24. 24, subtracting polynomials just like adding the opposite. It just makes it so much simpler. So this minus this is this plus, and it's plus negative x squared, because that's the opposite, and it's going to be positive 8x, that's the opposite, that's negative 2. So we can combine like terms, that's 4x squared, that's negative x squared, that's 3x squared, there's a 5x, that's a 8x, you combine them, you get like a 13x, then there's a 3, there's a minus 3, that looks like it's a plus 1. There you go. Subtracting is adding the opposite. Okay, so let's add negative 5w squared minus 6w plus 7. Alright, w squared, negative 5w squared, that's negative 4w squared. 11w, negative 6w, subtract them, you get like 5w. And then negative 4 plus 7, I think that's plus 3. There you go. That's how you subtract polynomials. And then when you multiply these polynomials, you can do it by distributive property or use by the box method. They're both good. So you can think that 6 times all that. So 6x times 2x minus 4. And then it's 3 plus 3 times all that. It still is 2x minus 4. So you just distribute 6x times 2x, that's like 12x to the second power. 6x times negative 4, that's negative 24x, plus 6x minus 12, and then you see that the two terms in the middle are like terms. So let's combine them. So you have 12x squared minus 18. Is it 18? It's not 18, is it? It might be 18. It's 24 minus 6. 24. That is 18. A negative 18x. And then it's minus 12. Okay. And that's how we multiply these polynomials. And now I'm going to try the box method. Since it's a 2 by 2, I'm going to make it a 2 by 2 box. So it's 3x minus 7, and then it's 5x plus 2. So we multiply what's in here. These two, that's going to be 15x squared. And then multiply these over here, that's negative 35x. And multiply these two here, like 6x. And multiply these two here, negative 14. So that's 15x squared minus 35x plus 6x minus 14. And then you can see these two are like terms. So you should combine them. So I think that's going to be negative, what's that, 29x minus 14. There we go. Y equals negative, let me check it, 35 minus 6. 29. Okay, that's legit. Alright, let's move on to 26. So this is a squaring of polynomials. So you can use the previous method to multiply these out, or you can use a shortcut. It's all the same. So here's the pattern for the shortcut. We have like hard plus triangle quantity square. You're going to square the first, like this over here. Then you square the last, that's this over here. And then you multiply this times 2. That's right there. There's your shortcut. But if there's a minus sign, then everything is the same except that's minus. That's still plus. So let's check it out. First we're going to square this. 3x. We're going to square that. And then it's going to be 2 times 3x times 2. And then it's going to be plus that square. 2 squared. There's your pattern. So you can go that square, that's going to be 9x squared, and then 2 times 3x times 2, that's going to be, I think that's 12x, is it? Yeah, 6x times 2, that's 12x. And then you square that and you get 4. Easy. Okay, this one, this has a minus sign. Okay, so same problem. Well, a similar problem, except that's going to be minus. So we square this, we're going to get 36x squared. And then 6x times negative 7, that's 6 times 7, that's 42. 42 times 2, that's 84. And then we square the last term, we get 49. The only thing that's different, one has a plus, one has a minus. Everything else is the same. And then we're looking to find out the greatest common factor between this and this and this. So between 6 and 15 and 21, you can factor out a 3. And then that's 8 to the 6th, that's 8 to the 5th, that's 8 to the 2nd. You can factor out 8 to the 2nd. And then b, that's 3 b's, this one is 5 b's, this has no b, so you can't factor out a b. And then I see this one has a d, but the others don't have a d, so that is your greatest common factor. What about down here? Between 5 and 25 and negative 35, you can factor out a 5. And this one's x squared, this one's x cubed, this one's x to the 6th. The most you can factor out is the smallest x, so that's x squared. And then this is y to the 6th, that's y to the 5th, that's y to the 2nd. Y to the 2nd, the smallest number, that's all you can factor out. There you go, that's 27. let's do 28. So 28 is about factoring trinomial when the leading coefficients are 1. That's really easy. You just have to ask yourself what multiplied to give you the last term and add up to give you the middle term. So for this, what multiplied to give you the last term, that's negative 35, and add up to the middle term, which is negative 2. So factors of 35, 1 and 35, 5 and 7. I'm pretty sure it's 5 and 7. But 7 has to be negative. So there it is. That means you just factored. So factors of x squared, x times x. And then it's going to be 5 negative 7 plus 5 minus 7. And this factors into this. You multiply these two, you get that. Alright, and then on this one, what multiplied to give you 30 and add up to negative 11? 5 and 6. No. Yes. 5 and 6, both negative. Negative 5, negative 6, add up to negative 11. X minus 5, x minus 6. There's your factorization. Alright, on to 29. So this one is not so easy because the leading coefficient is not a 1. But luckily it's a prime number, so it's going to be x and 5. Okay, so now this is 6, not a prime number. So this is a little bit tricky. It could be 1 and 6, it could be 2 and 3. 1 and 6, 1 and 6. No. 2 and 3, 2 and 3, 3 and 2, 2 and 3. 2 times 5 is 10, minus 3 is 7. It is 2 and 3. You see how the inside gives you the 10x and the outside gives you the 3x? If that was a negative, then that would give you a negative 7. So that's negative, and that has to be positive. And there's the factorization. Totally check out. Alright, do number 30, and then we'll take a little break. So now let's match parabolas and okay. So first find the zeros. So the zeros are the roots. It looks like it's at negative 1. And then no, it's not negative 1. It's, what is that? No, that is negative 1. And this is 1, 2, 3, 4, 5. It's 5. So one of the root is negative 1, one of the root is 5. So it's going to be y is equal to x minus negative 1 and x minus 5, or y is equal to x plus 1 times x minus 5. And there's your factorization that represents that function. Okay, let's take a break and then come back to one more and then we're done for the night.